So test and set is a basic synchronization primitive used mostly in operating system and concurrent programming to manage mutual exclusion. So it makes sure that only one process or a thread enters in the critical section at a time. So like this test and set operation does two things atomically, like meaning as a single uninterruptible step. Like for example, it reads the value of a lock variable and sets the lock variable to true or say one. And it then returns the original value that was in the lock. So like we say that atomicity of test and set is the reason that it is unique. The operation is done in one indivisible step. No other thread or process can enter or observe an half-done state. So as we stated that it works with a single flag or a bit and guarantees that no more processes can enter and change the states. So like this is how exactly this can be mapped. So as an atomic operation. Okay. So like if we have to see the structure of it or design of it as in a pseudocode perspective, one can think of that it is a Boolean variable, test and set. So which sets the target. So old is one variable that we are using and target value we are setting and then we are passing the old value. So here what exactly it is doing, reads the current value of the target, sets the target to true and returns the original value that was read. Now we'll see this as an program perspective here. We'll try to write a program which will really address this test and set or introduce us test and set. So to do so, let us assume that like we'll be writing it through a C code, okay, or C program. Now here, this C program is explicitly going to be written, which we are going to make use of as a test and set to set and simulate an atomic test and set. So let us write Amax test and set.c. So let us include header files .h hash include unistd.h hash include stdlib.h hash include, because we are going to make use of boolean variable, so that's why we'll use stdbool.h. Then like we are going to make use of mmap, so that's why we have to include, so because we want to create a shared memory map, so hash include sys slash man.h. And like as we are going to make use of parent child kind of aspect, so we will require say that wait.h, okay, as in a process perspective. So let us include sys slash wait.h. Okay. Now the way that we saw before a while, like we'll try to write that function test and set, and we'll take a variable of type boolean. So we'll use the same variable as target, the one we saw before a while. So in the code, we said we declared one variable bool old is equal to start target. Then we'll modify target value target, okay, to true, and then we will return old value. Fine. So this is our test and set function. Now we'll try to write a critical section problem. Okay. So let us create a critical section. So void critical section, and this will include the process ID. So process ID in the sense we'll refer it as process 0, process 1 kind of. So process ID, and we'll just print it here using printf. Like I am entering into critical section. So process %d entering in critical section. We can pass the PID as well if required. Like whatever you think better, you can make use of it. So right now I'll use simply process ID. We may modify it. We'll modify probably. Okay. Then we'll sleep for a while so that we want that process to execute in the critical section. And then we'll write the similar one to say that we are leaving the critical section. So process ID leaving critical section. Fine. Now this is our critical section function. Okay. Now what we'll do is we have to use this function in a process. So what are the processes that are forked? We'll call one function, okay, where we will execute this critical section for the process, and appropriately we have to see like a test and set should get executed. So let us write one function. So this function would be responsible for like this would be called by each forked process, and this will repeatedly try to acquire the lock using test and set. This is our main goal. So let us say process work, and we'll pass process ID the way that we earlier wrote, and then the lock value, which is Boolean. Fine. Now in this code, like we'll keep checking whether who acquired the lock. Fine. So like we'll write if. Now we will call the function test and set, and then we'll pass this lock value to there. Okay, what are the value that is given? So if not this, then we will execute critical section of that process, critical underscore section of that process ID. And once this process executes, we'll change the lock so to false, because that process that process ID will change that lock, and then we'll break from here. Fine. So that we don't want to continue that execution, so that's why we are using break. Else, like if it doesn't work, then process should retry to get access. That's what we have to write here. So printf process %d, it is trying to gain the access of the resource, but that resource is not available. So resource seems busy, and it is retrying. Say /n. Okay. And then similarly, we'll write the process which is trying for the resource, the process ID. Then we'll ask it for wait for a while. Otherwise, it will continue showing this message to us. Okay. Sleep 1. And then this else is part is done. This while part is done. This function is done. Now we have to write the main function, where in the main function, what we'll do is this lock variable that we created, we will create a memory, shared memory, okay, for this lock variable using mmap. And then we'll fork two child processes Both of them will attempt to enter the critical section. Now, let us try to write that function. And so integer main, then we'll write, we have to create that memory map now. So enter lock. So the way that we created earlier, in the similar way, we will create mmap. We'll call mmap. We don't want to give address. So size of bool. Okay. Then we will use the similar kind of constants that we used earlier. Protection, protection read, as well as put write. Now, like while we write these, this prot read and kind of what you can call it as constants, they are used with what you can call it as the functions, okay, like mmap, so that like whatever the memory area that would be keeping or taking, they should be uh, what you can call it as like protection. They should be using these protection flags. So these are protection flags. So for example, when we say prot read, pages may be read. Prot write, pages may be write. Okay. So together, this means that memory can be both read and uh, can be written into. Similarly, like we are going to make use of some flags which will be meaning for, say for example, mapping flags. So we have to make use of those mapping flags now. So these mapping flags would be used as a second parameter, a third parameter. So like I will write now map shared. So earlier we used to write it as map anonymous. Map anonymous. Fine. And then we don't want anything there. So that's why -1 and 0. Fine. Sorry, I wrote one extra and then done. So we created this map now. So we have to create, we have to see whether the particular memory mapping is done or not for lock. So you can check this like this. Okay. So if lock is equal to, if it is not created, then we will say that mmap failed. So this is a constant variable internally used. So this is used whenever a mmap function fails, then this gets executed. So error mmap failed. Okay, and then you can simply exit. This was just to like introduce you like how exactly you can make use of if suppose your memory mapping mmap fails. Now initially what we'll do is we will set this lock to false. Okay, then we'll have to create the structures. Okay, with the PID two process we want. So child one and child two. So let us say for process one, we'll give create a process, a child process with one child. Okay, now with assumption that both the functions, what you can call it as, both of them would be creating the children's. Okay, and we want them to execute the respective codes. Okay, that are meant for the processes. So both processes are created. Let us say. So now once this is created and if it is a child process, so because we want to execute into child process. So if PID1 is equal to 0, okay, then what we want is we want to execute process task. So process work. So what are the process work function that we wrote above? Okay. So this process work we are going to make use of. And then we will say that we will pass the ID, process ID. So you can write here, say maybe get PID, or you can simply write like I don't know 1 and 2. So right now I would be saying that this is my first process and I will pass the lock value. Okay. And once it is done, it should complete the execution and terminate the code. And similarly, like we'll copy this code and we have to execute it for this PID2 too. So this is for PID2. And process work value would be now 2. Correct. Now once it is done, everything is done. Now as this is a parent process, so we'll use wait call for children to finish the execution. And towards the end, we will unmap the memory which is mapped as. We'll use m unmap. Okay. So like write this void star the way that we wrote because it is an address. So lock and then size of bool because we took that parameter above. Accordingly, we are going to make use of it. Fine. Now this is done. Then you simply write return 0. Okay, hopefully this program should work. So we'll try to see whether it works. GCC, and if there are errors, that we will try to work out with them. Okay, good. It worked well. So when we execute, you can see entering in the critical section. Now process 2 was trying because process 1 has entered in the critical section. It hasn't left the critical section. That's why process 2 could not acquire the lock. Correct. So then it requested, it kept trying. Then again process 1 leaving the critical section. Till the process 1 was leaving the critical section, process 2 also has tried again. Then again it got success. Process 2 got the success, it entered in the critical section and then left the critical section. So if we execute it one more time, let us see how it works. So number of stages you can see here. We required 1, 2, 3, 4, 5, 6. Here we record 1, 2, 3, 4, 5. Correct. So it depends on availability of the resources too. Correct. So like process one was trying, but process two was given chance probably to enter the critical section. Okay. Then process one was also again trying to access, but again it could not gain access because process two was having control of lock. Then it left. Then again process one got the chance. So you can keep executing this to see like which one is giving the chance, which process was given the chance. Right. So this is how the test and set lock mechanism works.